This installment is going to be primarily related to determination of sex, but I had mentioned in the previous installment about the Howells data set. I didn't call it that though. I said inside Fordisk there is a massive data set, and I talked about the Forensic Anthropology Data Bank. The other massive data set that we use to determine things like sex and ancestry from skeletal remains is this one. And this one is readily available on the internet. So if you search Howells and craniometric data, this will pop up, and I've just downloaded it, and I just want to show it to you so you can understand the concepts a little bit better. So if I scroll to the side, all of these numbers are linear measurements that are taken from one point to another on the skull. So gall, for instance, is front to back. So all of these are just massive measurements. And by all of these, I mean all of them. So every one of these columns is a measurement. So going down, these are population groups. So Howells was a famous anthropologist, and he had a bunch of students that worked for him over the years, and basically they traveled to different museums around the world, and they collected these measurements from different skeletal collections. And they only used known samples so that they can say all of these people are from what they've labeled this Norse population. They've labeled whether they're male or female, and all of this would be inside Fordisk too, also for that Forensic Anthropology Data Bank. And so if you measure your unknown skull and you run the statistics on it, it will compare it to all of these. And I'm going to scroll down farther, but first I want to show you. So in Norse, there are a bunch of male skulls, there are a bunch of female skulls. Zalavar is another population. Berg is another population. So it just goes on and on and on. So the Forensic Anthropology Data Bank now has about 4,000 or more people in it. This one is fairly static because it's a historic data set. So it's got about 3,000 in it. So this, for instance, is the data set that I used for a lot of my dissertation looking at metrics. So this is pretty common, and it's that discriminant function analysis that allows us to group ancestry, and also you can do the same thing with sex. In the Forensic Anthropology Data Bank, they also, when we start talking about stature and age even, they have all of that data. So it's a little bit more extensive than this Howells data set, but this is the idea. All right, so let's talk then about determination of sex. So I like to start with this picture because you should be able to tell just by looking. If I ask you, what's the sex of this individual, you can tell that this is a female because it has what at this point, because it's not through the birth canal, would still be a fetus in there. And so if it's a fair assumption to say this person, without getting any closer than this picture will allow, it's a fair assumption to say that these two may have died in childbirth because this baby is breech. So you can tell this is a female. It is not that simple most of the time. So I started the ancestry lecture by talking about the difference between ancestry and ethnicity and race. And I said, don't use them interchangeably. You will lose lots of points, and that is true. Sex and gender are not interchangeable terms. They are not synonymous. They don't mean the same thing. Sex is a biological attribute. Gender is cultural. Now, interestingly, culturally, we really group people into two sexes, male or female. But if you take a genetics class, I teach a genetics class, if you take a genetics class and you learn about sex chromosomes, you will actually discover that there's more, it's not quite that simple. And so we do oversimplify sex sometimes. We now culturally are going through a sort of gender revolution, and we're realizing, man and woman, those are not the only two genders. If you went back in time 50 years, they are, right? The recognized major genders in our culture. And now we realize, there are many, many more. And so this becomes increasingly complicated, and it is critical that you understand that there is a difference between sex and gender, that sex is biological, gender is cultural. So, as a biological anthropologist, forensic anthropologist, you can't determine gender. You can only determine sex. And much like with ancestry, the police asking you, come on, what's the race of this person? They're probably going to say, what's the gender of this person? And that's not something that you can actually answer. And yet, what you may find yourself doing is saying, oh, they're male. And so male actually is sex. But we just have this weird habit in our culture of using these interchangeably. In a science class, that is unacceptable. You will lose points. So please pay attention to the differences in these terms. All right. So sex determination has some caveats and addendums, just like everything else. You really peak in sexual expression, essentially, physically, between puberty and menopause or andropause. So menopause is a term that we talk about. Andropause is something that, again, culturally, we don't tend to talk about very often, but it's the male menopause. Males do go through effectively the same thing. It's a hormonal decline. So puberty is a hormonal increase. Meno or andropause is a hormonal decline. So between those two periods, that's when your body is producing the maximum, for your body, amount of sex hormone. And you know that bones are constantly growing and changing, right? Bones are constantly forming. And so the amount of sex hormone that's coursing through your body is actually going to impact your skeleton. And so it's between puberty and the pauses that the skeleton exhibits the most sexual characteristics. So with or without the skin on, this is my horrible joke for the lecture, with or without the skin on, the best place to determine sex is by looking in the pelvic region. Okay? And so that's how you can remember, because you will be asked on your quiz, what's the best region for sex determination? It's the pelvic region. Okay? You can do it with the skull, but it's not as accurate. So that is important to know, because we're about to talk in detail about that. So just like with ancestry, I've grouped this into metrics and non-metrics. So let's start with the non-metrics, that's anthroposcopic. These are done on a scale. And so, much like I said, sex isn't really as simple as male versus female. You can actually see that here. So there's a range of really 0 to 5, but 1 to 5 if you're looking at the skeleton, and what you're looking for is there, because 0 means like it was absent, or like that piece of the skeleton is absent, essentially, I can't see it, or it's damaged, or what have you. So a 1 is distinctly feminine, and a 5 is distinctly masculine. A 3 is ambiguous. It doesn't really look toward one end of the spectrum or the other, and 2 sits between the 3 and either extreme, 2 and 4. So these pictures, they've actually made pictures like this for most of the attributes that you can scale like this, and this is really, like, literally with the pictures in hand, how most of us do these anthroposcopic traits. So you make a comparison to the image. So you collect these. This happens to be of the skull, but we have this for the pelvic region as well. So male sex hormone, so testosterone certainly, but there are others, make the skeleton more robust. And so what you see in the skull and the pelvis is increased robusticity. However, what do you need in the pelvis that females absolutely need, that males do not need? Think for a minute, and maybe you're thinking the ability to give birth, right? So this is true. So robusticity has a lot to do with ruggedness for the skeleton, muscle attachments, but it doesn't mean that, for instance, the space that the birth canal occupies, that is bigger in females. So if you look at these images here, this is that birth canal space, or in the female's birth canal. You can tell that there's a lot more open space in the female than in the male. And so that's a huge difference in the pelvic region between males and females. So we see that with the greater sciatic notch, right? It's very acute in males and it's wide in females, or obtuse. You see it with the sacrum, which is curved in males, and it's less curved or straighter in females. You see it with the subpubic angle. It's much wider in females than males. And there are a couple of other ones that we'll see. Those are the easiest ones to look at in this picture, but there are other ones in the table. And so these characteristics are those distinct differences that really you don't want to just eyeball it and say, here's what this is. But you do want to make comparisons to known standards, and they make those in the form of those pictures. And they also make them in the form of casts, so like plaster replicas, and you can make comparisons to those. And so that's how a lot of this is actually done. Now, the best technique in terms of accuracy in all of forensic anthropology is this technique. It's called the Phoenix technique, and it is for sex determination. So you look at 3 regions of the pelvis, and they're all right in the pubic area, and you score them really just present or absent. And if you're trained, and if all 3 of them agree, then this is 95% accurate. Okay, so I've got these pictures here. So the ventral arc is this really, I call it a ridge, but then unfortunately this picture calls the other version a ridge. But it's this rim around the pubis, or at least on the front of the pubis. The subpubic concavity, which is this pinch, this is the ischiopubic ramus. It's the bridge that goes between the pubis and the ischium on the innominate. And so there's a pinch there, a concavity in females, and there's not one in males. And then if you turn the pubis, so you're looking right at the pubic symphysis, there is a ridge. So again, it's pinched basically in females and not in males. And so if you see the ventral arc, the subpubic concavity, and the medial aspect ridge, then there's a 95% chance that this individual is female. And so this Phoenix technique is really the most reliable technique in all of forensic anthropology. So if you're testifying and you want your reliability, the Phoenix technique is great for that. I mean, certainly with 4-disc, as we said before, it will tell you, what the accuracy is of any given test that you're running. It could be higher than that, but generally Phoenix wins the gold medal. So there are other methods for sex determination in the pelvis. Scoring the greater sciatic notch is good. It's just not something that you want to do all by itself and say, oh, this is really wide, it's clearly a female. You want to look at more than one thing. Another thing that may show up in your casework is the preauricular sulcus. So preauricular, the auricular surface is on the ilium. It's this bean-shaped thing right here. And a sulcus is a sunken region. So right in front, preauricular, right in front of the auricular surface is this sunken little region. It is larger in females than males. In fact, it's absent in many males. So the greater sciatic notch and the preauricular sulcus together are seen as pretty accurate methods for sex determination. Not as good as Phoenix, but pretty good. And then from the skull, the idea here, I talked about robusticity already, is, again, testosterone, etc., produces more muscle attachments. Female skulls are smoother. So these images that I already showed you, what you're looking at really is female skulls are smoother with less muscle attachments. And so that's a lot of what you're scoring there. So metrics then are really almost exclusively done on the skull. They're the same measurements that I just showed you at the start of this, but you can, instead of grouping all of those populations by the population, you can group them by male or female and run your discriminant function analysis and group your unknown skull into the male or female category. And so it's the same concept for metrics as what we talked about with ancestry, but it's just using the data a little bit differently. So some of those measurements are considered better than others, but generally they are overlapping. And then, could you technically measure postcrania for sex? Yes, but it's not really very reliable in the modern United States where we have a really diverse population. All right, so let's continue this biological profile discussion in the next installment, and we'll talk about age.